Now, how do we apply it? And so here, the inverse trig functions for these, we already talked about it. And so what you want to do is if you fill that in, again, we know that this one here is going to be quadrant 1 and quadrant 4, or quadrant -1 on there. And then it's going to be from negative 90 degrees to 90 degrees. And if we do it in radians, it's negative pi over 2 and to pi over 2. And then for the secant and the cosecant, it's quadrant 1 and quadrant 2. And then it's from 0 degrees to 180 degrees. And I guess and then from this one here is going to be from 0 radians. Notice how I don't put a little degree symbol. And then it's going to be to pi. Now, whether you use x or theta is because when you do the inverse here, you have to ask yourself, what is this inverse representing? Is it representing an angle, or is it representing the trig ratio? So one of the things you have to remember is that when you do something like this, is that you're going to have the sine of theta is equal to x. The x is the trig ratio. This here is the angle. So usually when you do the sine inverse, this is still going to be the angle. And this sine inverse is going to be your trig ratio. So that's what you're seeing over here. So when you see that, the angle that's being made is still theta, or you could call it beta, alpha, whatever you want to, but that's the angle that's going to be between there. And the x is actually your trig ratio. All of these are your trig ratios. And just keep in mind that anytime you have an inverse, a trig function and inverse, that this is the trig ratio. Anytime that you have the trig function and no inverse, then whatever follows is your angle. Okay, very good. So it says here, number 2, find the angle measured degrees. So you have to be careful in your calculator, whether you're in degrees or in radians, that satisfies the given statement and in what quadrant your calculator will be in when it's given to you. So in this case here, I have trig tangent of theta is equal to 2.214. Now here's the question. What quadrants is that going to be in? And so because I am going to, if I do the inverse on here, what calculator will you give it? Your calculator give it in is that you're going to have to do this, and you do the tangent inverse of 2.2145. And that number is okay to work with it. And so I know that that one there is going to be either in quadrants 1 or quadrants -1 or 4, which is the same angle there. Because it's positive, it's going to be definitely in quadrant 1. And so then what is the value going to be? Well, we're going to take our calculator, and then we're going to do the tangent inverse of that. So the way you do that is escape. We're going to do tangent inverse, and then notice how I'm in degrees on there, and we're going to put in 2.2145, and then we hit enter, and so that is your degrees. So it's 65.70. So we're going to have theta is approximately 65.70 degrees. Notice how I put the degrees, because if it's not there, I'm assuming that it's radians. Okay, so now what do I do here? Now here I don't need a calculator, because this is one of the left-hand rule ones, one of the basic quadrants angles that we know from there. And so the sine inverse, notice how this here is your trig ratio. And so what you have there is going to be the sine inverse of the square root of 2 over 2. So that means that I need to have, this tells me how many fingers of, I guess I shouldn't do it in that color. This here tells me how many fingers I should have below my bended finger, and that means 2. So that means it's going to be a 45-degree angle. Now, because it doesn't say whether we should be in degrees or in radians on there, it doesn't really matter there. So the sine inverse, the angle is going to be then, the angle is going to be 45 degrees. Now the trig ratio is positive, so it has to be in quadrant 1, because that's what sine says, it's quadrant 1. And so we put the little degree symbol there. Now if it was in In radians, I could just say pi over 4 on there. So either one would be right unless it actually told you to put it in one or the other. So in this case here, either answer would be right on there. So read the directions on what it's saying. Now, the other thing is, I know we've talked about inverse, but this is another, when it says arc, it's not that we're going to English class and say arc, who goes there? It's it's just arc tangent. So arc tangent is the same as the tangent inverse. So it's just another notation, more notations for you to know, and that those two are equivalent. That's what they're saying there. So those two mean the exact same thing. Now, again, this here then is because this is the tangent arc, the arc tangent, and this is the inverse, this still is your trig ratio. So what we're looking for is what quadrant. And in this case here, it's not a quadrant, it's a quadrantal angle. And so I know that tangent is going to be sine of theta over cosine of theta. And so when you have that, what you're going to do is figure out, we want it to be 0. So that means that cosine cannot be 0. That means that sine has to be 0. And so when that happens that is going to be at 0 degrees. So this is a quadrantal angle because it falls right on the positive x-axis. That's where it's falling. So in this case, theta is going to be 0 degrees, 0 radians, whichever one you want to do, that's what it's going to equal there. Okay. All right. So now, compositions of trig functions. So from what we know already, composition of trig functions is, well, compositions of any functions. What really means is that when you take one function and put it inside of another. So like say, for instance, I had x squared and I had x plus 2. I have two functions. I have f of x, and let's say that this one here is g of x, and I'm going to take one function and put it inside of the other function. So that means that I'm going to have f and then do g of x, let's say. So that means I have f, I have x plus 2. That means I'm going to take this x plus 2 and put it into that. So that means I'm taking the g of x, which is this function right here. I put it in there. And so now I'm going to put that there. So it's x plus 2 quantity squared. That's what compositions of functions is. So here, composition of trig functions, if you notice, I have a sine function inside of a cosine function. And so this one here, it's a sine inverse function. So therefore, the 1/2 is a trig ratio, not an angle. But this one does not have an inverse. So that means that this whole entire thing, the answer that I get, is going to have to be an angle, which makes sense because if I do this is a trig ratio, so if this here inside is a trig ratio, when I calculate this part right here, that's going to give me an angle. Let's do it there. Okay, so it's going to give me an angle, and then I'm going to have cosine of that angle, and therefore then I'm going to be able to get there. My final answer is going to be a trig ratio. Okay, so how do I do it? I'm going to start from the inside out. So I'm going to start with evaluating the sine inverse of 1/2. So 1/2, that means that I have one finger above the bended finger, and so that means it's going to give me 60 degrees. It doesn't say whether I should be in radians or degrees, whichever one is easier for you. And so I'm going to say that we're going to have the cosine, and the sine inverse is because the trig ratio is positive, has to be in the first quadrant. So it's going to be and I think I said the wrong angle there. It's not 60 degrees, it's 30 degrees. And so we're going to have the cosine inverse, the cosine of 30 degrees because the sine inverse of 1/2 equals 30 degrees. So now I do the cosine of 30 degrees, and that gives me the square root of 3 over 2. And that is my answer. Okay, so now let's look at number 10 again. composition of functions. So what we do here is we're going to do the inside first. The -1 is a trig ratio. So when is tangent equal to 1? Well, tangent is equal to 1 when sine and cosine are equal to each other, and that's at 45-degree angle. But this one here is negative. So it is 45, but it's going to be in a negative 45 because tangent inverse is restricted to quadrants 1 and -1 or 4. And so we know that this one here is now going to be in quadrant 4. So I know it's falling right about here, negative 45 degrees, negative pi over 4. So what is the trig? In this case here, the trig ratio is -1. The inverse is going to be an angle. So this one here is going to give me sine of negative 45 degrees. And what is the sine of negative 45 degrees? That one there is going to give me square root of 2 over 2, and sine is negative in the fourth quadrant, so it's going to give me a negative square root of 2 over 2. Okay, going on to the sine inverse cotangent. Now notice how we have this here. So notice now we have cotangent, but the cotangent does not have an inverse there. And so therefore this here has to be an angle. Remember, just because it has pi does not make it an angle. Pi is just a number. And so I could have pi and still be a trig ratio. What tells us that this is an angle is because it does not have an inverse here. So this one here is an angle. And we want to know the cotangent of pi over 4. Now the cotangent is going to be negative. So therefore, we need to know in which angle it's going to fill, what quadrant it's going to be in. And the cotangent to be negative is either going to put it in quadrants 2 or quadrants 4. This one here is not the inverse, so it doesn't have to be restricted. So it just says that the cosine is going to be negative. So it's either going to be in quadrants 2 or it's going to be in quadrant 4. Either one would work on there. The only thing is that in quadrants 2 and in quadrants 4, sine is negative in either one. So it doesn't really matter in this case. So I could say the sine inverse and pi over 4 is going to give me the same thing that we just did with tangent. It's a 45 degree. It's going to be the same thing on the numerator and the denominator because cosine and sine are the same. So that means that I am going to get -1 as my answer there. So the cotangent of pi over 4 is 1, and then it's negative, so it's going to be in either one of those quadrants. No, that is not right. Okay, so now we are going to this. Okay, so now we're going to do this one here. And if you notice here, we have the cotangent of negative pi over 4. Well, negative pi over 4, you have to look at pi is a number. So it could be a trig ratio here, even if it has pi. That doesn't tell you that it's an angle. So even though you have pi over 4 here, what tells you whether it is an angle is that this here does not have a -1. So this here cannot be a trig ratio. So what tells you whether it's an angle is this part right here. And negative pi over 4 just means that it's going to be this angle going down here and negative pi over 4. So that's the same thing as the 45 degrees. So when you're doing this, you're going to find the sine inverse, and then you're going to do the cotangent of negative pi over 4. Well, pi over 4 for cotangent cotangent and tangent, they're pretty much the same. They're just inverses of each other. And we did 10 where it was -1, and it was a 45 pi over 4 angle. So the cotangent is just a reciprocal, which is going to be the same. So this one here is going to be -1. So now we have to do the sine of -1. In order for us to do the sine of -1, that means because it's the inverse, it's going to be restricted. So it's either going to be restricted in quadrant here or in this quadrant. But because it's -1 and not one of those, it's either going to happen here or it's going to happen there. Because it's -1, we know it's happening down here. And so my answer here has to be, because it's the inverse, it's going to be restricted, and it's going to be 90 degrees. That's what it is. But because our angle is given in radians, we want this angles to be in radians as well. It is -90 degrees, and it's correct, but we have to follow with what the angles are given to us there. So if something in a problem is given to you in radians, your answer should also be in radians and not in degrees. So in this case here, it would be -pi/2 is your answer. Okay, so let's do the next problems here. These are all calculators where calculator problems and where you're going to put them on there. And it's pretty much the same thing. And you could do the degrees and the radians on there. And so you do the cosine inverse of 0.6752 on there. So we know that it's an inverse function. So this here is a trig ratio. So if that's a trig ratio, what quadrant is this trig ratio going to be? And that gives us to be in quadrant 1. Now, how do I find the degrees? Again, we go back to our calculator and we put that into our calculator here. And so we are going to be able to, let's see, what is it? Okay, so we're going to say tangent cosine inverse, and we're going to put in 0.6752. You hit enter, and that's going to be your degrees on there. Now, it also asks for radians. So this is your degrees. So then what you're going to do is go to the battery part up here, and then change your angles there to radians, make that default, say okay, and now let's try that again. Now, I don't have to type it up. I could just use this part right here and then hit enter, and then hit enter, and now I am in radians. And so that's how you would use that to manipulate it. Okay, so now we go back to where we were. Where were we? Right here. Okay, so now we go back here and we fill in those answers. So we know that in degrees, we're going to get approximately 47.53 degrees and 0.83 radians. We do not need to write down radians. We just know that if there's nothing there, it's just going to be radians on there. And then doing these types of problems here, these are also going to be important because when you have tangent inverse and then tangent again, do these two cancel each other out and we get 5 pi over 4. Sometimes it's true, sometimes it's not. So what you do is you're going to have to follow again. Now notice this is 5 pi over 4. There is no inverse here, so we know that this is an angle. So when we do the tangent of 5 pi over 4, we are going to be able to do the counting on there. So we're doing the pi's over 4, so that's how we're looking at it. So it's going to be 0, 1, 2, 3, 4, and 5. So we know that it's going to fall in here. So, and it is a 45-degree angle. We know that because it's being divisible by 4. So what you do here is you do the tangent inverse. And then we know that that's going to be 1 because it's a 45-degree angle for tangent in the third quadrant. That is true. When I take the tangent inverse of that, because now the inverse is restricted between quadrants, it's restricted in this quadrant and in this quadrant, this no longer is in quadrant 3. Now it's in quadrant 4. So your answer to this is not going to be 5 pi over 4 because anytime you have an inverse, it's going to be in one of those. So it's either going to be -45 or +45. So in this case here, it's pi over 4 because my angle given here is in radians. My answer should be in radians as well. And it's pi over 4 because tangent inverse is restricted to these two quadrants. Okay, let's try this one here. Now, this one here is tangent of negative pi over 4. So we know that this one here is restricted to this angle. And it's not even, the tangent is not even restricted. It's just negative pi over 4. And it's not restricted because it doesn't have the inverse. So it could be, tangent could be anywhere in that unit circle. The one that is restricted is the cosine inverse. So we need to evaluate the tangent of pi over 4. So the tangent of pi over 4 is going to be um, -1 because its tangent in the fourth quadrant is negative, so it's -1. And so now I have the inverse. Well, cosine is restricted in quadrants 1 and in quadrants 2. So this negative part has to be in quadrants 2 right here. And it's saying cosine inverse of -1. And so -1 is not falling anywhere in that quadrant, but on the quadrantal angle right here. So in this case, is this answer right there. And so it's going to be pi. Again, radians, so this one has to be radians. It cannot be 180 degrees there. And so that is the answer to that one. So in this problem here, we have 5 pi over 12. You might not recognize it as one of our standard angles. I know it's in radians because it doesn't have the degree symbol. So I want to evaluate it and see. I know that pi over 2 actually happens right there. So, and I know that the sine and is not restricted at all, but the sine inverse is restricted to quadrants 1 and 4, or what we say, -1. So we know it's restricted there or here. So if the function actually, if the angle that we're talking about, the sine of that angle, we need to figure out 5 pi over 12, put it in our calculator, and it becomes approximately 1.3. I know that pi over 2, the top of the first quadrant, is approximately 1.6. So I know that 5 pi over 12 is actually falling somewhere in the first quadrant. So if it's falling in the same restrictions, this is what it's saying. I'm saying the sine of this angle is going to give me this trig ratio. So the sine inverse of this trig ratio is going to give me that angle. So it's going to be the exact same thing. So the rule is if if it falls, if the angle and the trig ratio fall within the restricted first quadrant and fourth quadrant, one or -1 quadrant, then it's always going to be the same answer that's here. That goes true for sine, tangent, and cosecant. So for cosine and sine, it would actually fall in quadrants 1 and 2. If they fall within that, then it's no work that you need to do. It's going to actually give it to you the same answer. So for example, here, sine inverse sine, and it's a negative, that's okay. It falls in this quadrant, whereas where sine is restricted. Therefore, my answer is just going to be -5 pi over 12. No work to be done. So you just have to know the restrictions. If they fall within the restrictions, this angle or the inverse falls within the restrictions, is just going to be the same answer. Here, that's not this, it is true here, but the one thing is that sine inverse, we know this here is now the trig ratio. In any trig function, the highest trig ratio that it could be for just regular sine is going to be 1. Since this is above 1, it is not going to be an answer, and so therefore doesn't work. No solution there. And then this one's here. One of the things here is that that's why we learned our Pythagorean triples, is that sometimes here's a trig ratio. It's not a common trig ratio that we know. So when you do the sine inverse of 3/4, it's still a trig ratio. So we 3/4 is positive, so we're going to put it in the first quadrant, and it's going to be the inverse is going to either fall in the first quadrant or in the -4th quadrant, because we're talking about the inverse and its restrictions. And so therefore we're going to do opposite over hypotenuse. And so here it's going to get a little bit more crazy, because you are going to have to like figure out this side right here. So when we do the opposite over hypotenuse, and then you're going to do the cosine, so you're going to take this angle right there, and so the cosine is now going to be, for this answer, is whatever that is over 4. So you have to calculate it using the Pythagorean theorem. So it's going to be 4 squared is equal to 3 squared, and I'm just going to call that x right there, plus x squared. And so we end up with 16 minus 9 is equal to x squared. And so we end up with 7 is equal to x squared. And so we take the square root of both sides. Because we're talking about a distance, we take the positive. So it's going to be the square root of 7 over 4. And then you do the same thing for this problem right there. And we are going to then do, it's the tangent, it's the inverse, so it's positive, it's going to be in the first quadrant, and so tangent is going to be opposite over adjacent, and so we know that this here, unlike this one here, this is not a Pythagorean triple, because this side would have to be 4 and that would have to be 5. That's why we get the square root of 7 over 4. In this case here, I have the 7 and the 24, and I know that the other one is going to be 25 because those are the Pythagorean triples there. And so I want to find the cosine of this angle. The cosine of that angle is going to be 24 over 25, and that's how you solve that. Very good.